So this exercise is to demonstrate the use of the debugger, of the Visual Studio Code debugger, and the construction of a memory map. So, step one, let's write a simple program. So here I'll say, I know it's kind of getting like we've done it a lot, but adding numbers is sort of a simple thing to do. So it'll be a number adding program. In fact, the reason the first computers were built in the 1940s was to do the calculations to build the atomic bomb, because the Allies were fighting against the Nazis and they wanted to not let the enemy get it first. So number crunching is the original computer programming problem. Guys, everybody, the exact first second, like the instant you're not totally lockstepped with me, put up your hand, say, talk more about that, right? Because after this, starting from tomorrow, it's going to start getting faster with, JavaScript, and next week we're going to get into frameworks, and the week after that, I think our course is over. So please, I'm not in the room to see your facial expressions. Anybody who's not able to follow and get the same result on your own computer, let me know right away. Put your hand up. So here we're going to make a couple of variables. We'll call them A, B, and C, which is boring, but it's the best I can do. And let's make some constants. Let's call them X, Y, and Z. And here let's say A equals 1, because why not? B equals 2, and C equals 3. And here we'll make a for loop this time. And again, this is probably something I will give you on the lab test. I'll give you code like that and say, will it work? And I hope your answer is yes. It'll actually be an infinite loop. Because in a for loop, we have an execution context here. We can put any code we want. Here we have a conditional which must evaluate to true or false. And here we have another execution context. And here for right now, let's just put a little placeholder code. We'll just say console.log happy. And if I ran that, I hope you would all have no problem recognizing it would be an infinite loop. So let's try it. We'll say save. And we'll run our code down here. We'll say node. Is there anybody who is not following? Now, as they say when you're getting married, speak now or forever hold your peace. My wife's upstairs, so I have to say this quietly, but the term forever takes on a whole separate meaning when you're married. But anyway, that's not relevant to what we're talking about. We're all good so far. Good. So let's try running it and see what happens. So save. And node. I still called it practice 1. Okay, good. Practice 1. Yeah, no questions so far. Good. Good. Infinite loop, which I get out of how. I hold the control key and I tap the letter C. Nice. Well, let's do something a bit more interesting. Let's dump out the values of some of our variables. Sum is, and here we'll say A these are going to be your lab test questions. Shh, I'm not really supposed to tell you. So here, we'll save this again. And why not? Let's run it again and see what happens. And it'll keep running until the number gets too big to be handled. Then it would crash eventually because the number would be bigger than the memory variable could handle. So once again, Control-C to get out. Now, we did say we were going to talk about the debugger, didn't we? Step number 1 in using the debugger. Step number 1 in using the debugger. We always begin by putting breakpoints. Yeah, that's easy. When I get to the part that's hard, tell me. Because I don't think it's hard. But I understand when something is new, you know the old expression, they say thinking is hard work? What that literally means is when you're exposed to new knowledge and information, your brain generates hormones and chemicals to get your brain cells to hook together in a different way. It's called brain plasticity. You should go and research how your brain works because it's important. You're going to be using it most of your life. So, if you feel this is hard, it's not really hard. It's just not familiar. But when we do a bunch of examples, it'll get familiar and then you'll get comfortable with it. So we begin by putting in breakpoints, by putting in breakpoints. A breakpoint is a line of code, I guess is a good way to describe it, at which the debugger will pause and then you can do what? You can examine variables. Basically, there's only 2 reasons you ever use the debugger. Right? Only 2. That's it. No more. You can examine the values of variables. And what else? Expressions. I can take an expression which may have several parts, and it'll let me know whether it's true or false, and expressions. Or it could be numbers, right, that they add up together in a certain way. I'll demonstrate. So here we'll say you use the debugger for exactly 2 jobs. You use the debugger for 2 jobs, 2 things. Examine the state of variables and expressions. Examine the state of variables or the output or the value. Yeah, the value, the state or the value, I guess maybe is a more familiar term to you. Of variables and expressions. And my coffee is cold again, which I guess we need another break then in a minute. And the other thing you can do with it is trace out the flow of control. Oops. Oops, not that. Trace how it's going. Trace which method is calling another method. Trace whether it goes here or there in an if-then-else statement. Trace the flow of control. Trace. And these are all things which apply to all of your programming, right? You can take this to Java or to Swift or any other thing you work in. The flow of control, or depending which books you read, sometimes we say the flow of execution. All right, so we're here. Did I kill my debugging session? I think I did. I think when I started writing comments, I killed it. Well, anyway, it doesn't matter. So here I'm going to, oh, actually, no, I didn't put any debug points there. So I'll put a debug point there. And now I'll say run and debug. And you see here I have a call stack. I'll talk about the call stack later. We really need to talk about the von Neumann memory, von Neumann architecture to understand what's the call stack. It's basically the methods. Every time a method is called, you open another stack, and the call stack is a data structure in the runtime environment of the programming language, which keeps track of which memory address holds the instruction that's currently being executed. You don't need that for this test. I mean, we only have one test. You don't need to be, you're not going to be tested on that, but it's good to know. All right, so here I'm going to go to my watch, and these are from before, so I'll get rid of all of these. I'll say remove all expressions, and now I'll examine what's my A. Oops, and it's case sensitive, right? So it has to be lowercase a. I can edit. If I put a variable or an expression, I can change it. If I edit it, then it updates. So we'll say A. See, before it said unavailable, now it's saying 1. So a test question, is JavaScript case sensitive? Well, yeah, you just saw that it is. There's a fly here. Where did the fly come from? So we'll make that B, and we'll make it C. And we also want to look at X, Y, and Z, I suppose. X, Y, and Z. Look here. See, it's saying X, Y, and Z is undefined. Why? Because we haven't assigned to them yet. So they're there. They've been declared, but they have not been assigned to yet. And we also want some, I guess. So let's watch some. Not available because we haven't gotten there yet. It's not saying it's undefined. It's saying it's unavailable. Pay attention to that difference. Oh, actually, because sum isn't a variable. I don't have something called sum. All right, so let's select that and press delete to get rid of it. Remove expression. And just to demonstrate that you can do it, see, because I can also evaluate expressions. So I could have A plus B, right? I could keep track dynamically in real time of the combined effects of the combined values of different variables. And currently it's 3. So now I have my debug point, and this is going to be infinite, right? That's kind of boring, so let's change that. So here I'll say keep going while A is greater than B. And the way I have this set up, I'm not sure if that's ever going to happen. So let's get rid of that. Because A is initially 1. So initially, this isn't even true the first time. So let's do the following. Here I'll say A++, because I am going to test you a lot on things related to post increments, post decrement, pre-increment, pre-decrement, because that's something you should know about from Swift. So this will now be true the first time. I don't think so, but we can do this. So we'll say B minus minus. All right, let's save our program and stop and start the debugging cycle again. So I'll start debugging on line 19, and here I'll say run and debug. Am I going to go into my loop even the first time? Well, let's drop an expression, let's drop an evaluation on this expression. We'll say watch A is greater than B. That's true. So I will go into my loop at least the first time. But I don't want an infinite loop, so I have to write code that will become false at some point in the future, which I haven't done yet. So let's kill this. This would be an infinite loop, right? Because our variables are not being mutated. So here A is 2 and B is 1. Well, we could do this. We could do a post increment on B. And after I've done this exercise, if you still feel you don't need to understand it, or you still feel you don't totally understand it, the only solution, I'm going to put this in GitHub and I'll put the video up. You have to sit by yourself for a little while and just play with it, right? Like after I've shown you the pattern, the next step that's familiarity, and then comprehension is you doing it by yourself. So let's see you now. I'm going to end this debug session and save. Whoops, what did I do? So we'll say save and debug again. And everything that was true before still is. We're going to go into our loop at least one time. Now, as I'm progressing, as I'm clicking and saying go to next, you guys have a job. Your job is to pay attention to A and B and to this expression, A is greater than B. Because that's why we use the debugger. We use it to track the state of the variables. You can also change the value of a variable, right? You can jump in there and change it, which I'll show you later. And then we see if we have a complicated program, we trace which methods are calling each other. So now I'm going to go here and say step over. I'm on line 19. I'm now going to go into my loop. There I am on 21. So my ABC is 213. By the way, student who asked for the example of memory map, the debugger is giving us a memory map, right? We're the memory map exercise means you're going to figure out in your brain, you're going to keep track of what the code is doing, and you're going to write out the value of each variable at each step. So you're just going to, because to use the debugger, you have to be able to have an expectation of what the variables should be. Because if you don't know what they should be, then the debugger tells you what you are. Is that good or bad? Well, I don't know, because I don't know what they should have been. So that's why the memory map works well with the debugger. All right, so let's click on step over. So now I have 213. See, 213. Now I have 233. A is greater than B is now false. I will not go into the loop again. So I should now bail out and my program should be over. Right? So it is now, what time is it? Well, it's almost 11. We're going to... All right, guys, let me just wrap this up. Let me put this up here so you can have it. And then I think we need a break. And I'm going to ask anybody, in fact, everybody should do it, but especially if you're not clear on what I did, between now and tomorrow, practice this. If you still have questions tomorrow, let me know. But that's going to be very similar to your lab test, right? So let me end my video recording to start with. So we'll say end video.